items of maxima and minima. Problem number 5. 80 items are sold at the price of $20, while 20 items are sold at the price of $40. Find the price that will maximize the revenue and the revenue generated. This is the idea that there's a business owner, and he found that when the price was $20, 80 items were sold. Then a little while later, he decided he would charge $40 for the items, twice as much, and found that only 20 items sold. Now he's wondering, what is the price that he should charge that will maximize my revenue? And then, what is the revenue that it will gain from that price? So, first of all, we want to find a function for revenue. Revenue is found by knowing the current price. We'll call the current price X, times the current demand, or how many items people are actually purchasing from you. So, what remains is to find a function for demand. Now, the demand function essentially inputs a price and then says how many of those items are being sold. We want to create a demand function. I want to create a demand function that's going to be linear. One of the easier functions to create. For linear, we essentially need a slope and a y-intercept to create a linear function. This will be our linear demand. To create a slope, we need a number to serve as input, the x, and another number to serve as the output, we'll call that y, and then a second pair of numbers to serve as input and output. From this pair of input and output, we can develop the slope of the equation by taking y2 minus y1, which is the difference of the outputs, over x2 minus x1, which is the difference of the inputs. And again, we want the input of this function to be price, while the output will be demand. Well, we find here that when the price is $20, 80 items are sold. So that's an input of 20 as a price, and 80 items are demanded at that price. Next, we find that when we input $40 price, the demand becomes 20. So we input a price of $40, and the demand now is 20. We can use these two situations to create a slope, which will essentially give us a linear equation that will give us a demand function where the input is price and the output is the demand of the items that are being taken off your shelves. So I'm going to take, this is y2, this is y1, this is x2, and this is x1. So we get a slope of -3. Now, I want to have the y-intercept, so I'm going to plug this in to slope-intercept for x, the 80 in for y, and the -3 for the m, and solve for b. Negative 3 times 20 will give me negative 60. And then I add 60 to both sides. That gives me a y-intercept of B is 140. This implies that the demand equation will be D equals negative 3 times X. X is serving as the price. Plus 140. Also, this suggests that if you sold these for $0, the price is $0, that 140 items would leave, which would be basically your inventory. Every time you raise it by $1, people will buy 3 less of the inventory of 140. Okay, so revenue will be a function of X, be X times negative 3X plus 140. This implies that revenue is negative 3x squared plus 140x. Now I'm going to take the derivative of the revenue function and set it equal to 0. Negative 6x plus 40, set equal to 0. If I add 6x to both sides, I'm going to get positive 6x equals 140. Divide both sides by 6. And I'll have a price of, let's see here, I can take half of this, 70 over 3. And 3 goes into 7 a couple times. And that'll leave 10, and 3 will go into 10 3 times. And I'm going to get a repeating 3. Make sure I get a repeating 3. Yeah, I will get a repeating 3. So, I need to sell these items at $23.33. And that will maximize my price. So I tried $20, I tried $40, but I need to try about $23.33. Now the final question is, now that I know the price that will maximize my revenue, my question is, what will be my revenue generated? So I go back to my revenue equation. Which is negative 3x squared plus 140 times x. And I plug in the price of $23.33. And from here I want to let my calculator do the rest of my work for me. Okay, so, and I get a revenue of $1,600. $33 and 33 cents.